Continuing our talk about linear functions and whatnot, we're going to talk about a very special kind of linear function, and that's called direct variation. Simply, that just means that the equation always goes through the origin, or 0, 0. So that means in our y equals mx plus b equation, b is always 0. So our y-intercept is always 0, 0, making our equation y equals mx, or in this case they use the letter a for your constant. So we're going to look at a couple different ways. If I know a specific point, what would the graph look like? What does the equation look like? Or if I gave you an equation, how do I know if it's direct variation or not? So let's start with knowing that the point -4, comma 8 is on the graph. And we do in fact have direct variation. So I know I want my equation to be y equals a times x. So I'm going to plug the point -4, 8 in for x and y and solve for a. So my y value would be 8 and my x value is -4. So I have a times -4 equals 8. So I'm going to divide both sides by -4, which gives me a equals -2. So the equation I'm going to graph is y equals -2x. So I know it goes through 0, 0, and then I use the slope -2, and so I'm going to go down 2 and over 1. I'm just going to do that several times, and it should go through the point -4, 8. Which it does in fact, because that's this point right here. And then I would just connect the points. Now in order to go, so forwards I go down 2 to the right 1. To go backwards I'm going to go up 2 and to the left 1. So I just reverse the fractions sign so that I can get it. So alright, let's look at, let's look at some of these others. Okay, so we're going to go through the point 3 comma -9, I should say. Okay, so we've got 3 comma -9. I'm going to use the same process by plugging in the -9 for y and the 3 for the x. Whoops. I said plug in 3 and then I wrote x. And then when I divide both sides by 3, I'm going to get a equals -3. So I'm going to graph the equation y equals -3x. The b value is 0, 0, so I'm going to go down 1, 2, 3 and over 1, 1, 2, 3 and over 1, and so on, 1, 2, 3 and over 1, and then go backwards. I'm going to go up 1, 2, 3 and to the left 1, up 1, 2, 3 to the left 1, and so on. Sorry, it's really hard to draw a straight line on the iPad. Okay, one more. It's -7 comma 4, so that means the 4 is going to go in for y. Let's change colors here. So I'm going to put the 4 in for y and -7 in for x. So now when I divide both sides by -7, I'm going to get the equation y equals -4/7 x. Now you can leave the negative with the 7. It doesn't really matter where the negative is. So again, I go through the point 0, 0, and I'm going to go down 1, 2, 3, 4, and to the right 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to do it the opposite way, so I'm going to go up 1, 2, 3, 4, and to the left 7. 1, 2, 3, 4, 5, 6, 7, and connect those dots. So I want you to try number 3. Alright, so what happens if instead of asking you to write the equation, it wants to know if a given equation is in fact direct variation model. So basically I want to solve them so that they say y equals, and I want to know, do they follow y equals a times x? If they do not, then it's not direct variation. So for the first one, I'm going to first add the 4y over to both sides, so that I have 3x is equal to 4y. Divide both sides by 3, or excuse me, by 4, because I want to get y by itself. I'm running out of space here. Let me just write a little bit smaller here for you guys. So I'm going to add 4y, and that's going to give me 3x equals +4y, and then to get y by itself, I'm going to divide by 4. So it gives me the equation y equals 3 over 4x, which does in fact follow y equals a number times x. So this one is direct variation. Okay, let's compare that to b, where if I add the y over, now I have 2x equals 5 plus y, and if I subtract the 5 to get y by itself, I have 2x minus 5 equals y, which does not follow the y equals a times x. So what I want you to do now is see, but first thing you need to do is to carry the 3 through the parentheses. So multiply that 3 by the x and by the negative 4, then work on getting the equation to say y equals, to tell me if it's direct variation or not. Last but not least, we can decide using a chart of values if we have a direct variation model. So we're going to look at these two models, both of them representing the length of a shark tooth. And so if I want to know if it represents y equals a times x, first thing I'm going to do is find the slope between the first 2 points, and then use the equation that I get to see if the rest of it follows suit. So I'm going to find my slope. So in this case, we're going to call it a, and I'm going to take y2 minus y1. So that's the 290 minus 215 over 2.4 minus 1.8. So that gives me 75 over 0.6, which is 125. So if this is direct variation, my equation is y equals 125 times x. So what I'm going to do then is plug in the next point in for x and y and see if for x, and see if I get out to the y value. If I do, then I move on to the next one and make sure they all work. If it doesn't, then it's not direct variation. So let's see. So I'm going to take, and I want to know, does y equal, so in this case, 350, does 350 equal 125 times 2.9? When I type it into my calculator, I do not get 350, so it is not direct variation. Okay, so you're going to try the second one. Again, find the slope between the first 2 points, get your equation like we did in the other one, and then plug in the 2.9 and see if you get out 145. Plug in the 3.6, see if you get out 180, and so forth. If it works for all of them, then you do, in fact, have direct variation.